Okay, so we have already finished discussing what pressure is. Now let's talk about liquid pressure or pressure in a liquid. Oopsie, let me change the font color. Let's talk about pressure in a liquid. So, or when I talk about liquid pressure is defined as the weight density of the fluid, or sorry, weight density of the fluid multiplied by the depth. Okay. Okay, so we have there the pressure is equal to weight density, which is equal to rho times g multiplied by the depth, which is h. So where P stands for liquid pressure, rho stands for the density of the fluid, G obviously as well known as the gravity, acceleration due to gravity, which is 9.8 meters per second squared, and h, that is the fluid depth. So what does this formula tell us? Fluid pressure is equal to the weight density rho g multiplied by the depth of the fluid, which is h. So it tells us that pressure is directly proportional to the density and also directly proportional to the depth of the fluid. The denser the fluid, the greater the pressure. The lower you go, the deeper you go in the fluid, the higher the pressure would be. So let's explain that. So how would we explain that? For example, when you go to when you have a dam over here, let's say we have a large lake. We have a lake, okay? So let's define this as a large but shallow lake. Let's compare the fluid pressure over here when we have a small but deep pond. So we have here a deep pond. It's the same pond. Well, but it is, well, comparatively deeper. So this is a small but deep pond. If you're going to construct a dam between the two, okay, so the average pressure acting against the dam, kunyari may dam dito, ayan, may dam tayo. And over here, let's have also a dam. Okay, so let's say, yeah, so the average pressure acting against the dam depends on the average depth of the water, okay, depends on the depth of the water, but not on the volume of water that's being held back. Over here, dito, marami tayong water. We have, well, it's a large lake. So there's more water here. More water. However, dito, we only have, well, less water, obviously. But the pressure exerted on the dam is greater over here than that of the pressure exerted in the dam over here. Why? So we have there dito, we have less pressure. Over there, we would have a greater pressure. Because as we have defined earlier, pressure is equal to rho g h. Oopsie, let me write that down. So we have the pressure is equal to rho gh, it's the density times gravity times height. So the depth of the meter, let's say, of the water over here, let's say, is about 3 meters. And over here, let's say the depth of the water, is about, say, 6 meters. Between the two, they have the same contents, the same raw, the same value for G, but different depth. So pressure is greater, obviously, here on the small but deep pond as compared to the pressure exerted on the dam by the large but shallow lake. So that's how pressure differs as we go down. But take note, so at different points we have their increasing pressure. As we go deeper into the pond, the pressure increases. Just like in a submarine, okay, or under the sea, at the bottommost part of the ocean, the pressure is large as compared to the topmost part of the ocean. Let's have another example over here. So another example, let's suppose we have a glass container. Oh, I haven't changed the font style. Okay, so let's have a glass container. See, and my glass container over here contains, well, obviously water. Okay, we're going to define points in my glass. So there's water inside, water, okay, water, okay, and let's place a fish to make things interesting. Fishy. Okay, so where's the pressure greatest among the three? So let's define some points. Okay, let's have here point A. Let's have another point here, B. Let's have another point, C. And let's name another point D. So at all these points, the pressure at point A, how do we compare the pressure at these points? The pressure at point B, pressure at point B, the pressure at point C, and then the pressure at point D. The pressure at each of these points are just the same. So again, we use the formula. Pressure is equal to rho times gravity times height, or the depth. They would have the same depth going from A to B, from the top of the water going to each point. They would have the same depth, same G, and the same height. So they would all have the same pressure. But if we have, name another point, let's have another point E. At point E, the pressure would be greater than any of this. Oops, sorry, it's not equal. At point E, okay, point E, the pressure is greater than any of these pressures over here. It's greater than A, B, C, and D, because point E is deeper, right? It has more depth than the other three. Let's name another point. Let's name another point G. Point G, how would we compare now the pressure here? The pressure here is now smaller. So that's how we compute for the pressure for a liquid. Okay? So I hope you understand the formula for liquid pressure. Let's recall that the formula for liquid pressure is rho GH. The deeper you are submersed in a fluid, the greater the pressure. Thank you.